Factoring special products. So we have two types of things that we would consider special products when it comes to factoring. All right, these guys are. You don't have to write this, but some polynomials can be factored by rule without breaking down and without using a process, and these guys are called your special products. Okay, all of those steps that we did on the other problems, they're kind of rendered irrelevant in these special types. All right, so the first one is called a perfect square trinomial. You want to write this down. Okay, a perfect square trinomial in our standard form ax squared plus bx plus c. If a and c are perfect squares, if a and c are perfect squares, you can apply this rule. So the first thing you have to do, you find the square root of your a term, square root of your c term. 2, check that the product of the two terms times 2 is b, and then plug the terms into the rule below. So if it turns out to be a problem that everything is positive, put in your p, and you have the square root of your a term plus square root of your c term, quantity squared. That means you just have that same parentheses twice. Okay, if b is negative, then you should be a minus there. I'll fix that. Put a minus in between it. Now, that looks kind of ugly with those roots in there, but I'll show you here in a minute. It's really slick and easy. We good? You still writing? Good? Okay, here's an example. H squared plus 8h plus 16. All right, so first off, is my a term a perfect square? Yep. It's square, and what number would be in front of it? 1, so 1's a perfect square of 1, right? Is 16 a perfect square? Yeah. All right, so what I like to do, I like to just kind of come over here to the side, and the square root of a is just h, and then square root of c is going to be what? 4. Okay, it's a perfect square. Now, what is 4 times h? Times 2. Did it work? Yeah. Okay, so that was the second thing you had to do. All right, after you found the square root for both of them, check, just do a last minute check that the product of the two terms times 2 is b. Okay, so I found my root was h, my root was 4. 4 times h is 4h times 2 is 8, so I'm good to go. That's just your check. Now, everything's a plus, right? Okay, so plug it right into that form. Square root of A plus square root of C, quantity squared. That would be the same. If you go through and factor this the old school way, then you would end up with this. H plus 4, H plus 4. Okay? And all this means here is just that set of parentheses twice. All right? Is that easy enough? That's it. You're done. That's you're done. Because that is your two sets of parentheses. That's it. You're done. Okay? Okay? Like I said, this is a special cases. These are just shortcuts for certain cases. Okay? Let's look at one that's a little bit tougher. No. Okay, so this one we don't have, or A is not 1. Okay, so by tradition, by factoring, as soon as your A is not 1, it makes it a little tougher, right? Now, look at your A term, 9x squared. Is that a perfect square? Yeah, what's the square root of A? 3x. Okay, is your C term a perfect square? Yeah, 7. So square root of C is 7. All right, is your B term, let's check and make sure real quick, what's 7 times negative 3? Times 2? Negative 42.
Wait, what did you positive 42?
7 times negative 3 is negative 21 times 2, negative 42. Okay, so we're good. It fits. All right? Sorry, that's not negative. Sorry, you don't have to worry about the negative sign on that one. Okay? So, 3 and 7 is 21. 21 times 2 is 42. We're good. Okay? Don't worry about the negative sign. Don't. Now, if we look back here, if B is less than 0, then what? You put a minus sign in there. Square root of your A, 3x. Square root of your C, 7. Minus in between, square the whole thing. Done. It's factored.
Whoa.
Okay? Questions? Okay. This guy. I'm going to give you two of them. Okay, there's one.
Alright, how does this
There you go. Now they're all the same. Okay, there you go. It should take you a minute, tops.
The boy is lost.
Okay.
What?
Number 1.
No.
What's the square root of your A term? 5. 5x. What's the square root of your C term? 4. What's 4 times 5x? 20x times 2. Am I good? Yep, I'm good. So, my parentheses, what's the first number? 5x. Second one is 4, plus or minus in the middle? Plus, square. Done. Okay? Number 2, what's the square root of A? 8z. What's the square root of C? 7. Okay, 7 times 8 is? 56 times 2 is? 112, so we're good. 8z, 7, plus or minus in the middle. Why is it minus? There we go. Good. Done. Yeah, that's the first type of special product. Pretty simple, right?
No.
Second one's even easier yet. What?
What do we distribute the two first?
What two?
He is lost. He's lost. 64.
No, no. The square means that parentheses twice. It means two of the same factor. That set of parentheses written twice.
Why?
This is like a 1 second deal.
Yeah, I know, but not it.
Okay, I'll tell you what. You write this down, Vincent. This and this. This is what that means. Okay? You write that down and foil it. We're going to move on.
Yeah, but whenever we.
You don't distribute the two.
Why not? We do on every other lesson.
No, you did when it was all multiplication. This is not multiplication inside.
Yes, it is.
What is that?
Z times 8 is multiplication.
Okay. Difference of two squares. This is the second type of special product. This is even easier yet. This is if you have a binomial. Only two terms. There's no b term in this one. Now the big thing with this is you're going to have an ax squared term minus a c. It has to be a minus. It's called the difference of two squares. Has to be a minus. So if a and c are perfect squares with no b term, you can apply this rule. Find the square root of a and c. C term must be negative. Plug the terms into the rule below. In this case, it's very similar to the last one, except we have to have 1 plus, 1 minus. All right, it's the same two numbers, but it's 1 plus, 1 minus. So it might be x plus 2, x minus 2, for instance. And again, this only works if you have a minus c. If it's a plus c, you cannot use this rule. You didn't have any binomials in your homework, so you're good. And last night you didn't have any perfect square trinomials either. So, what you're going to find, these types here, when you're just factoring in general, if I give you 20 problems to factor of just all kinds of factoring, there might be like one of each of these. Okay, they're not very common. There's, perfect squares. There's 9 perfect squares in the first 100 numbers. So there's not a lot of options here. Okay, so I'd say, in the vast scheme of things, when it comes to factoring, these special products are maybe make up 10% of the problems you'll see. Now, obviously, when I give you a homework assignment and they're all of this form, all right, you finish writing that down, and then we'll move on to a couple examples. Okay, couple examples of this. We're going to do 3 overall, okay? You're going to have something like this. X squared minus 144. Only 2 terms there. There's no way we can break this down by our traditional polynomial rules, is there? All right, we can't. There's no b term, so I can't break down c and try to make it add to b, that kind of stuff. But is x squared a perfect square? Yeah, it's a perfect square of what? X. What's the perfect square? 144 is a perfect square of what? 12. Okay? Is there a minus in between? Yeah, so I'm good. First parenthesis, x plus 12. Second parenthesis, x minus 12. Done. Factored. Oh, this one's really easy. All right. Next one. M squared minus 225. Is m squared a perfect square? Yeah. Is 225 a perfect square? Yeah. All right. So, perfect square of this, square of this is m. What's the square root of 225? Sure? You sure? How about 15? Okay? All right. So, m and 15. It's a minus, so we're good. M plus 15. M minus 15. Done. Tell you what.
Yeah, come on, Lucas. This is almost tonight,
To
but
get some exercise. Lucas.
Fuck him for
Help
a
me.
walk.
Help me.
He's a salon, Lucas.
He's a soul.
Guys, go.
Yes, come on, Lucas.
Bye.
Lucas.
Now.
I need something to drink.
Have to take one extra step. All right? If this is the case here, like a third one, 80x squared minus 45. Now, is that a perfect square?
No.
No, 80 is not a perfect square. 81 would be, but 80 is not. But looking at that, I get an 80 and a 45. What can I do to that?
Pull out 5.
I can pull out a 5. I pull out a 5. Now I have 9x squared. Sorry, not 9x squared. Plus 9.
Draw a line.
What, 16?
No. 8.
Yes.
It's not 8. Okay? 16x squared minus 9. Now do I have perfect squares? Yes, I do. All right, this is 4x. This guy would be 3. Okay, so 5 out front. 4x plus 3. 4x minus 3. Done. All right, questions? Yeah.
Does it matter if the plus or minus goes?
It does not matter. I usually go plus minus. That's just kind of convention. But it doesn't matter.
But you don't have to put a 5 before the minus.
Now, if you do have something factored out, you want the 5 the whole way to the left.
Not in front of the second one.
No. Okay, anytime, let me say that again. Anytime you have a GCF that you pulled out, it has to go the whole way to the left. It would be like whole number, parenthesis, parenthesis. Make sense? Questions on this lesson? It's pretty simple.